nutrition is a science that studies how nutrients and compounds in foods that are maybe not nutrients but are ingredients in the foods, how do they affect body? How do they influence body functions and overall health? And how do we use them? So nutrients, not all ingredients in foods are considered nutrients. So what considerations do we have to see or to say that an ingredient or a compound in a food is a nutrient? Well, nutrients in general are compounds that are important as building blocks of, for example, cells or tissues in our body, and they are important to sustain body processes. For example, some nutrients provide structure to our bones, like calcium, phosphorus, to our muscles, like proteins, or to tissues, cells in general, cell walls, like some kind of lipids. And nutrients also facilitate reactions and processes in the body. One big example is water is part of the fluids in our body that are important, for example, blood to transport oxygen, etc. And then some nutrients, not all of them, but some nutrients, they also provide energy. So they will be important for many functions in our body. And in addition, they could provide energy or not. One example of a nutrient that provides energy is glucose. Glucose is a type of carbs. We will learn about carbs in chapter 4. And glucose is a main source of energy for our brain. In physiological conditions, it's a source of energy for our brain and our red blood cells. So even if you decrease the amount of glucose in your body or in your diet, you need to care about being able to get the new glucose you need to sustain the function of your brain. It's important to understand that we can have compounds, and this is a specific example is alcohol. We can have compounds that provide us energy, and they do not give us any other advantage of in their intake. Alcohol, it gives us what we call empty calories because we don't get anything else. Alcohol is not a nutrient. It gives us energy, but we don't need alcohol to sustain any body process, any process in our body to build any component of our body. So alcohol is not a nutrient. There are 6 types of nutrients. So according to their structure, functions, etc., we mainly the type of the structure, we group the nutrients in 6 groups. Water is one nutrient. Carbohydrates is a group of nutrients. Vitamins, minerals, proteins, and fats. And at this very beginning of the semester, we will use also the term lipids. So we are referring to the same group of nutrients when we say fats and lipids. They are not exactly the same. We will see this in chapter 6. We will see the difference. But right now, for us, it's okay if you refer to this group using either the word fats or lipids. And by looking into these charts, you can say that water is about 60% of your body. It's not exactly, it's not always its exact number. It has some differences according to gender, age, etc. But it is always the most abundant nutrient in our body, and it is around 60%. It's also the most abundant nutrient in foods. You can see here, for example, broccoli is about 90% water. Difficult to believe, but yes, in the cells. And chicken breast also contains a lot of water. That's why when you cook some foods, even if you don't add water, you will see how much water you get while you are cooking these foods. Let's learn now, how do we classify nutrients? So we classify nutrients in different ways. The first consideration is about their structure. If a nutrient contains carbon as a chemical element in the structure, we refer to this as an organic nutrient. And you see here in this table that carbohydrates, lipids that we also will call fats at this point of the semester, proteins and vitamins, they all contain carbon as a chemical element. Therefore, we refer to them as organic. In contrast, water and minerals, they do not contain carbon, and therefore we refer to them as inorganic. It's important to understand that this concept of being an organic nutrient refers to the chemical structure, and this is different to what you see in the markets and in some websites when they refer to organic ingredients or organic nutrients. To refer to something is to something that is really organic foods. So organic foods refers to food that has been produced, let's say, naturally, with no additives, etc. We will learn more about this at the end of the semester. We are not talking about this right now. When we refer in this course, when we refer to an organic nutrient, we are talking to the chemical structure, and these are carbohydrates, lipids, proteins, and vitamins. Okay, this is not about organic foods that you see in the market. The other way of classifying nutrients is about is considering if we need them in large amount or in a small amount, and also if they provide energy or not. So macronutrients are nutrients needed in large amount, and they do provide energy. And these are carbohydrates, lipids, and proteins. Whereas micronutrients are needed in small amounts, and they do not provide energy. And these are vitamins and minerals. The word macro makes you think on how much do you need? So large or small amounts. Large amounts, the prefix macro makes you think on that. But I don't know why nutritionists decide to consider, at least in our book, they decide to consider macronutrient both large amounts and providing energy. So a nutrient should meet both considerations to be considered a macronutrient according to the information in the book we are using. That's why water is in none of these two groups, because it's in between. We need water in large amounts, so I would say it's a macronutrient, but it's not according to this consideration that takes into account if it's provide energy, and water does not provide energy. So water is like a special case, or at least in this course will be like a special case, because it's in between. It's needed in high amount like the macronutrient, but it does not provide energy like the micronutrients. So it's in none of these two groups. Another way of classifying nutrients is talking about if they provide energy, just that. So when in this course we refer to an energy yield nutrient, we are talking about those that give us energy. And these are carbohydrates, lipids, and proteins. So in next classes, when talking about how much energy do you get from a food, you only need to look into the carbohydrates, lipids, and protein content, because these are the only nutrients that provide energy. These are the energy yield nutrients. There are some sections in each group, and we won't care too much about them right now because we will learn about them in their specific chapters. So fiber is a type of carbohydrate, and it does not provide energy. And cholesterol is a type of lipids, and also we don't get calories from cholesterol. On the other hand, alcohol gives us energy, but it's not a nutrient. So I can't say that alcohol is an energy yield nutrient. So for the question, is it alcohol an energy yield nutrient? The answer is no, because the word nutrient here in the question makes this a false statement. So alcohol is not an energy yield nutrient. It gives us energy, but it's not a nutrient. Why is not a nutrient? We say that in the first slide, on the first slides, because it does not sustain any body process. It does not give us any other thing that just calories, and this is considered like empty calories. The other way of classifying nutrient is it is essential versus non-essential. And what does it mean? It's just about, do they depend on foods to get the amount that we need to fulfill the role of this nutrient in our body? Yes, this is essential. No, it's not essential. And I call your attention that all nutrients are important. So this is not about being important or not. All nutrients are important for some specific functions. But if we can get what we need, because our body is able to synthesize it, then this is not essential. If we can't and we depend on foods, then this is essential. For example, I would say that cholesterol is a nutrient, so it has some function in our body, even though some people think cholesterol is bad. Not exactly like that. We will learn about that in chapter 5. So we need cholesterol for some functions, but our body is able to produce the cholesterol you need to fulfill these functions. So cholesterol is a non-essential nutrient. However, water, you need water. Your body is able to synthesize water in some chemical reactions, but the amount is not enough to sustain all processes that require water in your body. So you depend on your intake. Water is an essential nutrient. And some nutrients, which are considered maybe non-essential, like vitamin D, because you are able to synthesize it, they can become essential in some conditions, in some diseases. Vitamin D, for example, if there is no, you are able to synthesize vitamin D, but you need sunlight and you need a healthy kidneys and liver. If you have some problems or health problems, you probably are not able to synthesize the amount that you need. If you are, for example, seniors, they stay at home, or people living in the north with not enough sunlight, they can have issues, and therefore they need to take care about the intake of vitamin D. That's why you see some milks that are fortified in vitamin D. And then let's talk about the calorie, which is the unit for to talk about energy in foods. When we refer how much energy do you get in foods, we really use the term calorie. What is this about? Well, this is a unit that comes from science in general. So before any information about nutrition or energy in foods, calorie is a unit that is used by scientists to refer to the amount of energy that is needed to rise the temperature of 1 gram of water by 1 Celsius degree. Here in the course, we won't care too much about this concept in this first paragraph, because we are more focused on the calorie content of foods. But I want to distinguish that this calorie with lower case that scientists has been used. If we have 1,000, this amount, it means 1,000 the amount required to rise the temperature of 1 gram of water by 1 Celsius degrees. We also refer to this as 1 kilocalorie, exactly as we do in life. Of 1,000 grams is 1 kilogram. And nutritionists decide to take this 1,000 times and call this calorie with uppercase. And this one is the unit that we use to refer to energy in foods. So when you read the nutrition label, you will see that they use, let's say, 60 calories in a food item. And they use a calorie with uppercase. And it's important to see the difference because it's 1,000 times calories with lowercase. I know it's confusing. I just want to call your attention that there is a difference. And in nutrition science, we just use calorie with uppercase. And we can calculate calories in foods. So when you go to the market, so again, here in this course, we will be talking about 1 calorie with uppercase or 1 kilocalorie with lowercase. In this case, sorry, in this word. When you go to the market and you see a food label like this one, and it tells you that you have, let's focus on this part, 220 calories per serving. And in the next chapter, we will talk a little bit about this concept of the serving size. So when it tells you 220 calories, it should be true, of course, because it's in the label, but you can see if it's true. You can do some calculations to see if it's true, or you can do your calculations for when in a meal to know how many calories do you get in one day, how many calories in a meal. We will do it for assignment 1, by the way. How? How do you do it? Well, because we know how many calories a gram of carbohydrate or a gram of protein or a gram of lipids represents. So calories and proteins has a calorie content of 4 calories per gram, whereas lipids, they have a highest calorie content. It means 9 calories per gram. So if you want to calculate calories from fats or calories from lipids or calories from protein, you can do it by multiplying the amount of grams times these numbers. 4 in the case of carbohydrates, 9 in the case of lipids. I will make a second video showing you this slide and making some calculations to show you how to do it. To have a shorter video now, I will continue, and any calculations from the slides here, I will have it in a second video, okay? But I will show you that yes, there are 220 calories per serving by doing this type of calculation. And also, I go back to the example of alcohol, which is not a nutrient, but it gives us calories, and per every gram of alcohol, we have 7 calories. So it means, let's suppose you are drinking a beer, it will probably have carbohydrates. So grams of carbohydrates times 4, it will tell you the calories from carbohydrates, but you can also get some calories from alcohol. So 7 calories per every gram of alcohol in the beer. The same type of calculations, you can do it to find, for example, total calories in a meal, like in this sandwich. How many calories from fats, proteins, and carbohydrates. And we also can show these values as percentage of the total. And I will do these calculations also in this second video I will be doing for you. Why these percentages are important? Because the proportion we are eating are also important. So it's not only how many calories or how many from carbohydrates, lipids. So how much this amount represents in a total. You are supposed to have some kind of balance in your diet and specific amount of calories coming from fats, from proteins, or from fats. And we will learn them in chapter 2. Let's finish with this part and let's try to make a summary. I will give you some time to see if you can answer this.